All right, so here we have part 2 of lesson 2.3, where we're focusing on the stretches and compressions of and reflections of sinusoidal functions. I want to start, before I do two examples of how to graph sinusoidal functions that have stretches and compressions and reflections, I want to first go over what we've completed and what we've covered so far over the last few lessons. Okay, so here is your equation of a sinusoidal function. And you know that this is interchangeable with the cosine function as well. All right, but let's start with the effect that we have done in our research that A has on our sinusoidal function. First off, we learn that our A value is multiplied by all y values in y equals sine x. All right, so whatever your A value is, you take that and you multiply it by all your y values in y equals sine x. Secondly, we learn that A is the amplitude. Okay, so A gives us our amplitude. Okay, and then lastly, the proper mathematical term for what that A value is doing to our function is it is vertically stretch slash compression. Okay, depending on the A value, if it's greater than 1, it's a vertical stretch. If it's between 0 and 1, it's a compression. Okay, by a factor of A. Right? And then lastly, if A is less than 0, meaning it's negative, it is reflected across the x-axis. So there's a lot there, obviously, right? A lot that we covered in what A does to our function. Next, let's look at K. There's also a lot to K as well. So K, we learn that is multiplied by our x values in y equals sine x. However, you're not just multiplying whatever your k is, you multiply what's actually happening. And so what we learned was that if k was 3, what's actually happening is a horizontal compression of a third. So you multiply what's actually happening to your x values. So multiplied by our x values in y equals sine x, in brackets I'm going to put multiply by reciprocal. So what that means is that if you have k of 3, you multiply by a third. Or if you have k of 1/4, you multiply your x values by 4. You're doing what's actually happening to your points. Secondly, we call this the horizontal stretch or compression by a factor of, and again, the reciprocal. So instead of just k, it's 1 over k, so the reciprocal. All right, so same thing as above. And lastly, well, second to last anyway, the period can be found if you know the k value. The period is equal to 360 divided by k. And now lastly, if k is less than 0, reflected across, this time, the y-axis. Okay, the y-axis. D and C were a little more straightforward. Okay, so D, for example, instead of being multiplied by our x values, remember, it only affected our x values left and right. Okay, we add or subtract. So add slash subtract to our x values of y equals sine x again. So the parent function y equals sine x. Okay? And then there was just a little trick. Well, first off, let's state what this is. This mathematically is called the horizontal translation. Okay? Or, so that's horizontal translation or phase shift. Oops. Phase shift left and right. Okay? And then there's one little trick is that if it says x minus 5, for example, even though it says minus 5, what you really do is you add or subtract the opposite sign to your x values. So use opposite sign from equation. All right, so if it says a plus 5, you do minus 5 to your x values. If it says minus 5, you do a plus 5 to your x values. Now, C is similar to D in that it is added or subtracted. The nice thing is there's no tricks to this. Add or subtract to this controls our movement up or down. Okay, therefore it's to our y values of y equals sine x. Okay, it's called the vertical translation, up or down. And one of the tricks here is that our C value is actually our equation of axis. It's the same thing as our equation of axis. Okay, important to note. Okay, let's try two examples. And I'm going to show you how to graph each one of these. So first off, it says determine the amplitude and period, then sketch the new function. So let's find the period. What's our k value? One half. So 360 divided by 0.5. Therefore, this is going to equal 720 degrees. That's what our period's going to be. Okay, it's good to know. It's going to help me when I'm doing my scale on my graph. Our amplitude, remember, you just have to look at your A value, which currently is -1, but you never state amplitude as a negative value. It's a measurement, okay? Just like you wouldn't say something is -15 inches, you would always say the positive value, okay? So the absolute value of it. So the amplitude is 1, okay? Because it's a -1. Therefore, the amplitude, the measurement, is 1. And remember what amplitude is. It's the measurement from your EOA, your equation of axis, to your maximum or to your minimum. Okay, we're going to graph our sine function here as well as this new function. So I'm going to use the space down here to first plot or to first figure out my parent function y equals sine x. Remember that you always use 0, 90, 180, 270, and 360. Y equals sine x starts at the EOA. Okay, now let's figure out our new point. So our new function is y equals negative times sine 1/2 of x. Sine of 1/2 times x. Okay, so our k value is is 1/2. Our a value is -1. Okay, now remember that k only affects x values and y only affects y values. And how does it affect them? It gets multiplied by those values. And if you see, there's no d, so d equals 0, c equals 0. So there's nothing to do with d and c here. It's just a and k. So let's figure out our new x values. Okay, What we're going to do is take all of our x's from our parent function, so all of these values, and multiply them by what? 1/2 or 2? 2. The reciprocal. So reciprocal of k is 2. What's actually happening is it's going to be double the period here. So we're going to double our x values. So we're going to take 2 and multiply it by all our x's. 2 times x. 2 times 0 is 0. 2 times 90 is 180. 2 times 180 is 360. 2 times 270 is 540. And 2 times 360 is 720. And look, we already found our period to be 720. And now we're showing here in our table that yes, in fact, one full rotation will be 720 degrees. Let's figure out our new y values. We're going to take our a, and it gets multiplied by our y's. So multiplied by all of these values here. So it's going to be -1 times y, all my y's. So -1 times 0, 0. -1 times 1, -1, 0, +1, and 0. So you can see this is getting reflected across the x-axis. All of our positive values are now negative, and our negatives are now positive on the y, for the y's. This is now, we're going to plot each of these. We're going to plot this. I'll do it in one color, and then I'll plot my new curve in another color. Okay, and again, I'm reiterating that there is no d and c, which means that there's 0, which means that I'm not adding or subtracting anything. Okay, now let's figure out a scale. I've got to get up to 720. Okay, so maybe we do, let's see, if every 4 lines I do a 90. Let's see if that works. 1, 2, 3, 4, 90. That should work. So 1, 2, 3, 90 right there. 1, 2, 3, 4, 180 right here. In fact, we're probably not using enough of our grid, but that's okay. 1, 2, 3, 4, 270. 1, 2, 3, 4. 450, right? 360 plus 90, 450. 540. 630. And then lastly, 720. So not bad. We're using a decent amount of our grid space here. Okay, and I'm going to draw both. And I only need to go up to here. Look at my highest y values. It's just 1s and -1s. So let's spread this out. Let's go by 4s. 1, 2, 3, 4, and call this 1. 1, 2, 3, 4, and call this -1. Okay? All right, so in green, I'll do y equals sine x. So 0, 0. 91, 180, 0, 270, -1, back to 360. Here's our curve. There's one period of y equals sine x. Now let's do our other function. So I need to plot 0, 0, 180, -1. See, it's getting reflected across the x-axis. 360, 0, and it's getting horizontally stretched by a factor of 2. Even though k is 1/2, it's getting stretched. The period is getting doubled here. 541. Sorry, I skipped 360, 0. No, I put that in there. Sorry about that. And then 720, 0. So it's going to start by going downwards. Okay, something along those lines. So from the parent function, it was reflected across the x-axis, right? It was horizontally stretched by a factor of 2. It didn't go up or down. It didn't go left or right. The equation of axis is 0 because our c value is 0, right? And our amplitude still stayed as 1. We know that. We checked. We figured that out already. Okay? And that's it. That is how you draw one period of each of those functions, or of primarily this function here. Let's do one more example. Okay? Just to kind of get the hang of this here. So let's start by finding the period in the amplitude. What's our k value? K is 2 and A is 3. So what's happening here? 360 divided by 2, that means our period now is only going to take 180 degrees. So this must be a horizontal compression. Okay, horizontal compression by a factor of 1/2. Okay, so there's my period. My A is simply 3. Okay, so now we're dealing with the cosine function. So when we set up our table, it's going to be for the cosine function. We're going to have new x's, new y's. Okay, let's start with 0. And remember, the cosine function starts at the maximum. Okay? All right, so if our function is this, and I know that my k is 2, which means what I'm really doing is multiplying my x's by 1/2. So 1 over k is 1/2. The reciprocal of k is 1/2, and my a is 3. Both of those get multiplied. So the k value gets multiplied by my old x values of y equals sine x. So it's going to be 1/2 times x, all my x values here. Instead of using 1 over 2, I'll just use 0.5 times x, make it a little bit easier. So 0.5 times 0, 0. 0.5 times 90, 45, and fill in the rest. Okay? My new y's, I now take my a and I multiply it by all my y values. It's getting vertically stretched by a factor of 3, vertically. That means my y values. So 3 times y is what I want to do. Multiply all my y's by 3. Okay? I'm going to plot my original function, my base function, and I'm going to plot my new function. Let's think of a scale. So I need to include 45s. I need to go by 45s in order to plot this side here, right? So I'm going to go by 45s here. I'm going to go every 3 lines, I'll plot a 45. Let's see if that works. So that I'm really going by 15s. So every third line, 45. It's going to work fairly nicely here. Okay, I probably could have used more of my grid, but that's okay. Right? So I'm going as high as 360, but I wanted to include my 45s because you can see my new x values are actually going by 45s and not by 90s. So I chose a scale that works for both graphs. They work, all of my x values are here, right? I went by 15s. and all the x values are there. So let's give this a go. And actually, our max y values now have to go up to +3 and -3. So let's see, if we skip a line, 1, 2, 3, nice, and -1, -2. And -3. Okay, so let's plot our cosine function. 1, 0 here. At 180, it goes to its minimum. At 270, back at 0, and then 360 back to its maximum. So it looks something like this. Okay, do the best you can to draw a smooth curve around there. Our new function is compressed horizontally, so the period's going to be within 180 here. It's going to be a lot tighter. So 0, 3, and it's vertically stretched by a factor of 3 as well, right? So the new y-intercept is at 3. 45, 0, 90, -3, which brings us back here, and then complete it at 180 degrees. Look at how much this has been compressed. Our base function, okay, has been compressed significantly to fit one period within there. And we know that because our k was 2, which means we're horizontally compressing by a factor of 1/2. The period's going to be in half the time. Okay? So that completes part 2 of this lesson. In the next lesson, we're going to put it all together with equations that have a, k, d, and c.